Hey guys, got a little gunsmithing project for you tonight. It's an AL2. It's an AL2 Beretta 12 gauge, and my customer wants a sleeve to hang a swivel stud from for a strap, because the end cap that he has doesn't have a spot for one, and he said that he couldn't find one, an aftermarket one, so I have to go ahead and machine a collar that's going to go in between the end cap here and the forearm. And basically the end cap has a major pitch diameter of the threads that we really need to be concerned with, and the as the OD measurement. And then here on the let me push the forearm back a little, you can see on the stud part here there's a radius here, like maybe I don't know, 60 thousandths to maybe a 40 thousandths radius here, and we're going to have to go ahead and machine that on the ID of our part. So we're going to have to figure out the maximum pitch diameter of the threads, the maximum OD measurement of this this stud part here, as well as we're going to have to sort of figure out our radius measurement here and the depth. So first things first, I'm going to go ahead and draw a little scaled little diagram, and then we can take our measurements. Okay, so first things first, I want to get the major pitch diameter of the threads here, and just going to use my outside digital mic to get it. Like 306 thousandths and 5/10. Okay. So we're going to call that 307 thousandths. Okay, so just come down here to our little diagram, our little blueprint, and we're just going to come out here, and our major pitch diameter is going to be 307 thousandths. All right. Now we got to get the, back this up a little bit. Now we got to get the OD measurement here of this wider part that sort of flares out, that has that radius on it. And that's going to be a little harder to get, but I can do it. Yeah, 313. So it's like 313 thousandths and like 6/10. So we're gonna say 314 thousandths. So we'll go down here to our blueprint, and we're gonna say 314 thousandths, right? For the outside diameter. Now we need to get a depth. We need to get a depth from where the smaller diameter is to where the radius of the larger diameter starts. So we can figure out, I can't put a caliper, I can't put a vernier caliper on this because it bumps into the outside of the forearm. So what I'm going to do is I'm going to use my depth mic, and I'm just going to measure to that shoulder, the top of that shoulder, which is like right there. And all I'm doing here is I'm putting the flat part of this depth mic on the flat part of this screw here. And when I turn this knob, it sends the barrel out, and you can get your reading here. So we're looking at forearm moved up on me a little bit. We're looking at And I'm going to give myself a couple thousandths here, because it doesn't have to be a super tight fit. We're looking at, you know, like a 5/1000th tolerance. We got like probably 669 thousandths, but we're gonna call it 670. So we're just gonna go ahead and write that down for reference. Right here. 670 thousandths. Now what we're going to do is we're going to come back up and we're going to get an overall length from the front of the forearm to the top of the screw. If the forearm doesn't move up on me first. Alright. So we're just going to get an overall length now. And let's see what we got. We got 600 and we're going to call it 624. We're going to call it 625 thousandths. Okay. So we got 625. We're going to write that for reference. So we're going to take our 670 and we're going to minus 625 thousandths, and that's going to give us 45 thousandths. Alright, and that's going to be the length of that. So that's going to give us minus equals 0.45 45 thousandths. Okay, so that 45 thousandths is the length from the front of the forearm to the top of that radius. And what we can do is, we can't really double check it, so we can go and see what 45 thousandths looks like on the vernier caliper. Okay, and then we can get an idea if that's, and that looks like about right to me. That looks about how big that is to me. That looks about 40 thousandths. So that's where we'll make our radius inside of our part, is we'll make it up 40 thousandths. So we'll make a 40 thousandths radius inside the internal inside diameter of our part. Now we got to get an idea of how an overall length. So what we're going to do is I'm going to take the cap and I'm going to spin it on there, and I'm just going to get an idea how tight it gets, how many turns we get here, and that's fully tight right there. Now I'm going to back it off and I'm going to count. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, about 8.5 turns. And I originally wanted to make this spacer 1/4 inch. So in order to do that, what I'm going to do is I'm going to set my mics 250 thousandths. That's 1/4 inch. And I'd like to see a 1/4 inch spacer in here. Let's see if I can show you that. That would be nice. So let's see what that would look like. So it'd be something like that. That size right there. This would be the gap that I'd be filling with my spacer. And let's just see how many threads that we actually have on. And I'm going to count here. 1, 2, 3. 3 full rotations. And I think that would probably be enough grip to do what we want to do. So we're going to say We're going to put our 45 thousandths here for our length. Okay. And okay, so now that we have all of our ID dimensions done, now let's go ahead and do the easy part and put make our OD dimensions for our part. Now we know that we want it to be 250 thousandths in length, so let's go ahead and kind of draw it out a little bit. And it'll be a nice little visual reference for us when we're machining. Not that it's really necessary, so let's go ahead and just sort of roughly draw our part here. And it's going to look pretty basic. I mean, it's going to be, we will chamfer these edges. These will be chamfered, but that's okay. So the outside dimension here is going to be, well, we don't know yet, but the overall length is, I'm going to put the dimensions up here for the overall length, as we already know is going to be 250 thousandths, and then the OD diameter is going to be, I'm going to match it up with the cap, so it's an even flowing line, and we're going to call it 809 thousandths and 5/10ths, but we're going to go ahead and call it 800 thousandths, 809 thousandths and like 3/10ths, but we're going to call it 810 thousandths. So we're just going to go ahead and put our 810 thousandths. Okay, so that's basically it. Now we can go ahead and mark on here so we remember to chamfer our edges. So that's going to be the outside dimensions, and that's going to be the inside dimensions. Now I'm going to go ahead and like the cap, okay, on let me show you the forearm here a little bit better. See if we can show. You can see that there's these little machined slots in here to receive the spring-loaded ball bearing in the cap, and that makes it more of a lock when you screw it on when you're shooting. It doesn't want to rattle off. So I'm going to do the same thing in this part that we're going to make here. We're going to put a spring-loaded ball bearing that's going to go because it's going to be between the cap and the forearm. Okay, so I'm going to go ahead and make a ball bearing that fits in here too. So that way, and then I'm going to machine divots on the face of the part to receive this ball bearing, spring-loaded ball bearing. That way it all kind of locks together nicely. So that's where we're at. Now we just have to pick our stock. Keep cut off ends over here. Go from there. From the lathe, these are little cutoffs. Let's see if we have anything over here. Candidate, folks. That will work. Pretty good. Alright, let's face the part. Alright. Looks pretty good, guys. It's a nice start. Nice freshly faced part. And